Kia ora tātou, welcome to this next video where we'll look at elimination reactions. There are two elimination reactions that we need to know. The first one involves alcohols. So if we have an alcohol, let's say we have butan-2-ol. So I'm choosing this one because we have what is called the pour gets poorer rule with elimination reactions. So that means that we're going to eliminate a water molecule from this alcohol. So we could either eliminate the water molecule being the OH and then the H next to it on that side, or we could eliminate the OH with the H next to it on that side. And depending on which way we go, we will end up with a different molecule. We'll end up with a double bond in a different place. So let's start off by eliminating, let's eliminate the middle one here. So we'll go do this one the blue way, and the reagent that we use here is concentrated sulfuric acid, H2SO4. So what that might look like in an exam is that you might be given an alcohol, and it'll say the alcohol is reacted with sulfuric acid. What will the product be? So you'll need to remember that there will be the water molecule excluded from it, and we'll end up with an alkene. So to draw this, we're going to have just those 4 carbons again. 1, 2, 3, 4. And so we're no longer going to have the hydroxyl group or the hydrogen there. So what we're going to have instead is a double bond. And then we just draw in the rest of the hydrogen. So we've got H, 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 all the way around. And so that's our product. We've got but-2-ene, so that the double bond is coming off the second carbon. We're also going to have a water molecule as well, because that's the H2O there that comes off it. We could also, if we now, let's use another colour, why not use red? If we go in this direction, we take off that hydrogen and that hydroxyl group, then we're going to end up with the double bond coming off that first carbon there. And so what that'll look like is but-1-ene as opposed to but-2-ene. So we've got 2 potential products from this elimination reaction, and we get water as well. So just like with addition reactions, there will be a major and a minor product. For addition reactions, we use the rule the rich get richer, and for elimination reactions, we use the rule the poor gets poorer. So in this case, we're talking about rich being having the most hydrogen atoms bonded to it, to the carbon. So this carbon here has the most hydrogen atoms because it's got 1, 2, 3 hydrogens bonded to it. And we're specifically talking about the carbons bonded either side of that carbon bonded to the hydroxyl group. This carbon here has just got 1, 2 hydrogens. So this carbon is the poorest carbon. This carbon is the richest carbon. So the poor gets poorer means that the major product is going to involve this carbon losing a hydrogen. So that will mean that this reaction here, this reaction here, where we've got the hydrogen being lost from this carbon here, will be the major product. So the major product is up here, and our minor product is going to be down here. Minor. And that's the elimination reaction of alcohols. So the other type of elimination reaction we can have is for haloalkanes, and we're going to do exactly the same length carbon chain, 2, 3, 4, and we'll do why not do a bromine? We'll do a bromine molecule coming off there, and then we've got hydrogens coming off the rest of the carbons. The reagent that we would use to do an elimination reaction of haloalkanes is potassium hydroxide. So KOH, and it would be an alcohol. The potassium hydroxide needs to be dissolved in alcohol for this to result in an elimination reaction. You might remember from substitution reactions that if we have potassium hydroxide aqueous, then we would substitute that bromine atom for a hydroxyl group. So it's important to know the difference between alcoholic potassium hydroxide and the products that it will produce, and aqueous potassium hydroxide. So the rest of this is just exactly the same as what we talked about before. We could either have the bromine and the hydrogen next to it, to the left of it, being eliminated, and then having a double bond formed between those two carbon atoms, or we could go in the other direction and have bromine and hydrogen on that side being eliminated and forming a double bond on that way. So let's draw it out quickly anyway. So we'll have our C, 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 C. So if we eliminate this hydrogen atom, we're going to get the double bond between those first two, the middle two carbons, and then we're just drawing the hydrogens around it. Hydrogen, hydrogen. And this one is going to be the major product. We will also get HBr as a result. And then if we were to go in the other way and eliminate this hydrogen atom, we're going to end up with a but 1N molecule, just like we had before. That will look like this. And hydrogen there, with HBr being produced. So that's all that we need to know for elimination reactions. Just remembering the reagents. If we've got alcoholic potassium hydroxide, then we'll eliminate the halogen and a hydrogen next to it for haloalkanes, and for alcohols, if we've got concentrated sulfuric acid, that's what we will get there. Thanks very much for watching. Join in for the next video.